Hello, I'm Dan Frith for Gestalt IT, and I'm joined today by Fazio, Intel's Senior Fellow. Today we're going to be talking about Intel Optane. Welcome, Al.
Thank you.
So Intel Optane brings together traditional DRAM and traditional NAND, combines them into one technology, and operates over a range of systems, buses, and CPU architectures. Many years of work went into Optane, so my first question is, at what point did you realize that taking a novel media like 3D XPoint, a disruptive technology, and combining it with Optane's memory subsystem would have this kind of impact on the storage media hierarchy?
Well, this is something that we've been looking at for a long while. We were concerned about the slowing of scaling of traditional DRAM, and we were concerned about the performance of NAND as it was scaling. And so we were seeing gaps that would come in the computing memory hierarchy. And so we started to think about what technology would be required to solve that problem going forward. And that's where we developed 3D XPoint. But really, it was a development that occurred in parallel of the material science silicon process technology with the system teams that were developing systems that can take advantage of this in a new computing hierarchy. And that's what we're seeing with Optane.
That's great. So I'd really like to understand more of the process behind the product development. Once you've developed a disruptive technology, what's involved in getting that working with applications? What were some of your biggest challenges?
You can kind of think about this as in three phases. The first phase is actually proving that the underlying technology works. This is the material science device physics of the 3D XPoint technology and getting that to work. Then the big challenge came in how do you put this into computing systems? How do you build solid state drives around this? How do you build persistent memory DIMMs and re-architect the computing system to take care of it? And that's more of the system architecture piece of it. Now it's really in the phase of putting it into applications and seeing how applications evolve with this. First, it will go into existing applications, and then it will start going into how applications are written around this new capability. And that's what we're starting to see. It's when people are now doing their application innovation on top of our innovation of Optane.
Okay, so can you tell me a little bit more about the background of this technology? Obviously, the industry's been pushing for more capacity, more speed, better durability. Can you talk about some of the major drivers behind Optane?
Well, I think that there's three main drivers that are in there. One is that the slowing of the DRAM scaling. And so DRAM is slowing down in its capacity growth. And so there's a cost capacity problem that emerges with DRAM. The second one is that while NAND is scaling very well, its performance is not keeping up with its scaling of capacity. And so its performance per capacity has been dropping. The third one is that if you take a look at the processing core counts have been increasing dramatically, which means they require more and more memory, more and more performance. And that's been opening up a gap. And so that's what we really targeted with regards to trying to figure out how do we have a technology, both in the material science, device physics of the media, along with how do you implement it in a system that can then solve that problem, the demands of higher core counts to be fed with a memory that can be feeding at high capacity and performance rates.
So finally, can you talk a little bit about how Optane will impact computer hardware architecture moving forward? It seems like this technology has reached into a number of different areas.
The first way is just think about it as a fast storage is one way. The second one is as large capacity in memory. But the real innovation, I think, is yet to come. And that's where we start thinking about persistent memory. Traditionally, computer architects think of memory as something that would be a load store. It's a hardware access to the memory. They think of storage as something that's so slow, they hand it off to the operating system, where the CPU does a context switch while the storage driver now takes care of the storage access, the reads or writes to and from the storage. In the case of Optane, we can think about it as a persistent memory. So now the semantics of memory and storage can be blurred into one. And now, as a result of that, you're going to see different system topologies, different way people are going to be writing their software now that the memory is persistent. And that's the innovation that our customers will be doing moving forward. And we're starting to see that in the industry. And I think that's where things will start really evolving over the next several years.
That's really awesome. Thanks again for your time, Al. That was great. I'm Dan Frith for Gestalt IT. You can follow us at Gestalt IT. You can find me on the Twitter at Penguin Punk. And thanks for your time today.